Now with these polynomial functions, let's talk about the idea of intercepts, the intercepts of a function. Another word they use for intercepts, another meaning for that, is we could call them zeros of a polynomial. And we're going to talk about that more in the next section, but that's a term they use for those intercepts as well. Not all intercepts, but the x-intercepts specifically. They call them zeros, or they call them roots. That's another name. So x-intercepts, zeros, or roots. So if you hear those words, you know you're talking about x-intercepts for this one here. Not for any of those, I mean, not for these here, but for problems in general, because you'll see those words come up. Like I said, a lot more in the next section. All right, so anyways, for the following exercises, find the intercepts of the function. So we can just try this first one here. And hopefully you can understand the difference between the factors and the x-intercepts. What I mean by that is, what makes t minus 1 0? Hopefully you guys see 1 does. So you know what? T equals 1 is an intercept, or a 0, or a root. And then if I look at the next factor, if I plug in a negative 2 there, that's also going to make it 0. So that's also a x-intercept, a 0, or a root. And then another one here is 3. So this actually has, when I look at 25, that has 3 x-intercepts. Now, if this says intercepts in general here, that's not just x-intercepts. It also wants y-intercepts then if it states intercepts in general. So to find the other one, the y-intercept, I plug in 0 for x, or t for the problem 25 here. So I just plug in 0 for t to get the y-intercepts. So then the y-intercept, and there's no other names for that, it's just the y-intercept. So that's going to be 2, 0 minus 1, 0 plus 2, 0 minus 3. And then I'm going to get for an answer here, that's going to be negative 1, 2, negative 3, 2, and I have an even number of negatives, so it's going to be positive. So it's going to be 4. 4 times 3 is 12, so positive 12. So my y-intercept is going to be 0, 12. So there we go. That's the number 25 there. So those aren't too bad. Now let's try number 28. That looks like a fun one. So that's f of x equals x cubed plus 27. I'm going to find the y-intercept first because that's really fast. And I just plug in 0 for x. So I'm going to get 27 for y. I can do that one in my head just because I'm just zeroing that out and I got 27 left. Okay, so let's find the other one now, the x-intercept. All right, that means I'm looking at where this is equal to 0. For what x can I plug something in? So I just write the equation down. X cubed plus 27 equals 0. And then what I'm going to do is I can move the 27 to the other side. X cubed equals negative 27, and then I can cube root both sides. This is always a little confusing to people at first, because they look at the cube root of negative 27 and say, oh, I can't do that. Actually, you can, because it's an odd integer, an odd index there. So I can actually do that. And the answer is actually x equals negative 3. Think about this here. It's really negative 3 times negative 3 times negative 3. That's 27. Negative 27 if you think about it. Because negative 3 and negative 3 is positive 9. Positive 9 times negative 3 is negative 27. Because it's an odd index, negatives under the square root symbol there, that radical symbol, is fine. And that's usually what throws us off. So I just wanted to show you that one there, just because it's a little bit different, and when you look at it, you might get confused. So there you go.